Okay, this one's it asks you to use formulas to find your answers, and I didn't necessarily give you this formula um, exactly in this way, but I'm going to give it to you. I'm going to write it here now just so you can see it. Um, you could do, if you imagine this as length times width times height, okay, and I'm going to call this L for the length. Actually, let's call this L for the length and call this W for the width and call this H for the height. Then what you're really doing is you're looking for a combination of two of them, like, I'd say it like this, like 2 times length times width plus 2 times length times height plus 2 times width times height. Right? You're going to get all three of those different dimensions multiplied together twice. Length times width, width times height, length times height. And then we're getting that on this, uh, two sides, opposite sides parallel. And so that's what it's going to look like. So we could say length times width would be that in there and that in there. Okay. Length times height would be that there and that there. And then width times height would be like that back side there and that front side there. Not sure if that was super clear there at that last one, but you get the idea. So let's do it. We've got the 2 times the length of 5 times the width of 10 plus 2 times the length of 5 times the height of 4 plus 2 times the width of 10 times the height of 4. And we calculate all this out. We get 100 plus 40 plus 80. And add it all together. That becomes 220. And what were the units? Feet squared. Okay, that's number 11. And I'll box that answer. That one's pretty straightforward. Whenever you have the rectangular prisms, like you see in number 11, you can just take the 3 dimensions and make all 3 pairs, length times width times height, width times height, and then when you do those, you got to double them because there's 2 sides each. Now the theorem 11-1 on page 700 says you want to add the lateral area. I'll just write this out. Lateral area plus 2 times the area of the base. Okay, and so I'm going to write in the formulas here. The lateral area is simply the perimeter times the height plus 2 times, and then what's going to be the base of this? Well, we know how to find a polygon, the area of a regular polygon, which is 1/2 apothem times perimeter. Okay, so you can see that the 2 times 1/2 is going to cancel out. So really, what we're going to get here, simplified, would be this out. So perimeter times height plus apothem times perimeter. We need to find that apothem height. Okay, so let's calculate that right now. We've got a regular octagon, and if I draw that down here, we got like this. Okay, forget about how beautiful or not beautiful that is, but we can then say, okay, for that central angle here, this angle here, we've got all 360 degrees divided by 8 because an octagon has 8 sides. So we have a 45-degree angle in there. And if we were to drop the apothem down, since we have a side length of 5 here down on the bottom, okay, oops, that's 5, then what do we want to do? We want to kind of separate that little triangle out. Here's the apothem, here's the side of that, and that side now is cut in half. This bottom base is now 2.5. This angle right up here, since we cut that in half, is now 22.5. And what we're looking for here is x. So if we're dealing with opposite and adjacent, which we are, trigonometry, and by the way, I'm going to box this section out here, and we'll work below. Okay, so excuse me, we've got opposite and adjacent, so this is tangent, so we can say the tangent of 22.5 is equal to the opposite side of 2.5 over the adjacent side of x. And if we then do what our rule says we're allowed to do, which is to swap these two to isolate x, then we get, as a result, x is equal to 2.5 over the tangent of 22.5, which then will be approximately equal to, and I just need to get a calculator to do this calculation. Let's see, 2.5 divided by tangent of 22.5. And we get 6.03 something something, so let's call it 6, approximately equal to 6. Hopefully that'll work for our calculations in the book. So we've got an apothem height of 6. Okay, and now we can get rid of all the rest because we found out what the apothem height is, and that's really what we needed all that for. So we can use that to plug it into the formula. Okay, apothem height of 6. So substitute in there, 6. Let's find out what the perimeter is. Well, there's 8 sides, and each one of them is measuring 5, so 8 times 5 is 40. So that's 40. Remember, we're adding this together with what we get for the lateral surface, which is the perimeter of 40 times the height of 22. Okay? So if we were to, I don't know if you can do this mental math, 4 times 22 is 88, so 40 times 22 is 880, and 6 times 4 is 24, so 6 times 40 is 240, and of course when we add those together we get 1,120, and what are the units? They are centimeters. We're talking about surface area, so it's centimeters squared. That's what we get. And let me just check that against the book. Pretty close. The book has 1,121 centimeters squared, and that probably came from what they actually kept in their calculator as the proper tangent, okay, and then did, or the proper apothem based on the tangent, and then when they multiply that by the perimeter, let me try that, multiply that by the perimeter of 40, and yeah, instead of getting 240, they got 241.4. So rounding off here, this is just a good little interesting lesson. Rounding off here, at this point to 6, instead of leaving it as 6.0355, once it gets multiplied by 40, that small little amount that we rounded off actually made a little bit of a difference. And this should have been, if we'd kept it accurate, 121 point, let's see, .42 something something. Okay, and since it didn't tell us where to round it off, oh yeah, it does, to the nearest whole number. So that makes that 121. So don't round too early. As you can see, I did, and my answer was off by a unit. Better answer is to keep that tangent in the calculator as its exact amount, multiply it by 40, and then you can add the rest on. Okay, so real answer, 1,000, we write it, 1,121 centimeters squared if you had not rounded that apothem length to a whole number 6.